Can you solve this using the real number system? I guess no. Now, if you look at this is an equation that I took from a university examination question. And if you notice, it is an exponential equation. And whenever you want to solve an exponential equation, you always introduce logarithm in order to find the value of s. So, if you look at this question now, what do you think? Do you think it's wise for us to introduce the logarithm at this initial time? Let's find out. If we introduce logarithm at this initial time, at the beginning, we have log 2s plus 8s raised to the power s is equals to log 130. If you look at this equation now, you find out that there is no rule of log that we can use to solve this equation. I've not seen anyone. Therefore, it is not wise for us to introduce log at the beginning. We clean it and then look at the equation again. And if you look at this equation again, you notice that there is this 2 and there's 8. Therefore, there is a relationship between 2 and 8. If we look at these two numbers, that means 8 is the same thing as 2 multiplies 2 multiplies 2, which is 2 multiplies to 4 multiplies to 8. We now have 2 raised to the power 3. And this is 2 raised to the power 3 is the same thing as 8. And we now apply this here. And when we do that, we now have 2 raised to the power s plus 2 raised to the power 3s, which can also be written as, which is equals to 130. This can also be written as 2 raised to the power s plus 2 raised to the power s raised to the power 3 is equals to 130. Remember the law of exponent that says a raised to the power m multiply n is equals to or the same thing as m multiplies n. This is the law of exponent. If we apply this here, we now have 2 raised to the power s plus 2 raised to the power s multiplies 3, which is equals to 130. This is also an exponential equation. Now, if you notice in this equation, there is a recurring value, and the recurring value there is 2 raised to the power s. And in mathematics, whenever you have a recurring value, you apply substitution method. Thus, this 2 raised to the power s is also recurring here. And for us to solve this kind of equation, we apply a substitution method, whereby you can substitute it with any alphabet or number. Example, especially alphabet. Example, let's substitute 2 raised to the power s. Let it be equals to 1. Do you get it? Let's 2 raised to the power s be equals to y. Therefore, we are going to substitute y into 2 raised to the power s, and here I have 2 raised to the power s. Let's bring it up. If we bring it up, we now have 2 raised to the power s is equals to y. Let's keep this here. 2 raised to the power s is equals to 1. Let's keep it here. We still come back to it. Now, we now have y. That's if we are substituting here. Y, because this 2 raised to plus. Remember, we have 2 raised to the power 3s. Therefore, we now have y raised to the power 3. Because of we have 2 raised to the power s3. And we've already stated 2 raised to the power s is equals to y. Therefore, we're now going to have y raised to the power 3, which will be equals to 130. And if you rearrange, we now have y raised to the power 3 plus y is equals to 130. The next thing to do is to minus 130 from both sides. And when we do that, minus 130, this we cancel itself. We have 0. We now have y raised to the power 3 plus y minus 130, which is equals to 0. The next thing for us to do in this cubic polynomial is for us to find the root of this polynomial. That's the root of this equation. Let's go. You will enjoy it more. If you followed me to this point, that means you enjoy what I'm doing. Kindly click the subscription button for you to enjoy more of the amazing videos that I will be dropping, and then click the like and share button. Now, let's get the root of this equation. And this equation, just like I say, is a polynomial. Therefore, we now have y raised to the power plus y minus 130 is equals to 0. For us to find the root of this equation, we make use of what is called rational root system or rational root theorem. And what does rational root theorem involve? It involves getting the factors of the constant of the equation. And what are the factors of this of the constant of this equation? And the constant of the equation is 130. The factors of this 130 involve 1, that's plus or minus 1, plus or minus 2, plus or minus 5. We even have plus or minus 10, and so on. We even have plus or minus 26, and so many of them, even plus or minus 130. So, we now, remember we are finding the root of this equation, and we are making use of rational root theorem. We say that we bring out the factors of the constant of the equation. And these are the constants of the equation. So, we are going to apply these constants here to find out if the constant is raised to power 3 and has to if itself minuses 130, will it be able to give us 0? Let's find out. Now we start with 1. 1 raised to power 3 plus 1 minus 130. 1 raised to power 3 is still 1 plus 1 is 2 minus 130. It will not give us 0, therefore it's negative. That's positive 1. Negative 1 raised to power 3 plus negative 1 minus 130. Will it give us 0? It will still not give us 0. Now, we apply to positive 2 plus 2 minus 130. Will it give us 0? 2 raised to power 3. 2 multiplies 2 multiplies 2 is 8. 8 plus 2 is 10. 10 minus 130 will still not give us 0. Then we apply negative 2 raised to power 3 plus 2 negative 2 minus 130. Will it still give us 0? Negative 8 plus negative 2 minus 130. No, it will still not give us 0. So this will go, this will go. These are not the rules. Then we apply positive 5. Now we have 5 raised to power 3 plus 5 minus 130. Will it give us 0? Let's solve together. 5 multiply 5 multiplies 5. We give us 5 times 5 is 25. 25 multiplies 5 is 125. Therefore, 125 plus 5 minus 130 will give us 0. 125 plus 5 is 130 already. Now, 130 minus 130 will give us 0. Therefore, our root is 5. So, remember, we said 2x is equal to y. Now we've gotten our root, which is the root of y, to be equals to 5. We've gotten our y to be equals to 5. So we remember this our substitution that we did, whereby we got 2x, 2 raised to the power s is equals to y. And now we've gotten the value of y, which is our root. Now we go back to this, our substitution. And when we do that, we have 2 raised to the power s is equals to y. Now our y is equals to 5. We now substitute. We now have 5. We now have 2 raised to the power s is equals to 5. Remember, we are looking for the value of s, and that is what we are asked to find here. Looking at this equation, if you remember at the beginning of this class, I said that whenever you have an exponential equation, you make use of logarithm in order to solve the problem of exponential equations. So now, You've come back to an exponential equation again. So you have to introduce a log for us to be able to solve this problem. You have to introduce logarithm. You have log 2 raised to the power s is equals to log 5. Now, remember the exponential rule that says log a base m is the same thing or is equals to m log a. And if we apply this here, we now have s log 2 is equals to log 5. For us to find the value of our s, we divide both sides by log 2. Divide both sides by log 2. And when we divide, we now have the value of our s. If we divide both sides by log 2, we now have s log 2 divided by log 2 is equals to log 5 divided by log 2. And when we cancel out, we now have the value of our s, which is s equals to log 5 log 2. And this is our answer. If you enjoyed this video, kindly subscribe, like, and share. Thank you.